Okay, so now we're going to talk about electrolytic cells. So you use metals every day. However, most metals are reactive and will oxidize to produce metal ions. With this reaction, they will eventually return to the Earth, combining with other substances to reform the ionic compounds from which they came. As indicated by their position in the activity series, gold and silver are two metals that do not oxidize as easily as other metals. This makes them extremely valuable because objects made of these metals will resist corrosion and probably last a long time. Unfortunately, it is usually too expensive to make an object entirely of these precious metals. Cost-effective alternative is to apply a very thin coating of corrosion-resistant metal to the surface of a susceptible metal. These protective coatings are applied using a variation of the voltaic cell called the electrolytic cell. Both cells involve chemical change and electrical energy. So an electrolytic cell is a chemical system in which non-spontaneous oxidation and reduction reactions are made to occur by the application of electrical energy. So the difference between these cells is that a voltaic cell uses chemical change to produce electrical energy, whereas an electrolytic cell uses electrical energy to produce chemical change. So many metal products manufactured today have a thin coating of a less corrosive metal added to their surface. In this process, the object to be coated is submerged in a solution containing metal ions that will eventually form the corrosion-resistant surface. An external source of electric energy supplies the energy to the electrons that flow through the two electrodes. One electrode connects to the object to be coated, and the other, or a second electrode, in the conducting solution to complete the circuit. This process is called electroplating. So you will have an opportunity to build an electrolytic cell that can electroplate copper onto a carbon electrode in the next investigation. So electroplating is the process of depositing a metal at a cathode in an electrolytic cell. So looking at electroplating, the mechanics of the electrolytic cell. So earlier we explored the idea that batteries make use of spontaneous oxidation and reduction reactions. Energy is released at as relatively reactive metals lose electrons in the relatively reactive ions. The resulting current of electrons is guided through a wire so that the energy can be captured and used by your electronic devices. So this is showing you here the mechanics of our electroplating. So electroplating, however, is a process that forces a non-spontaneous oxidation and reduction reactions to occur. Energy is used to remove electrons from a metal located at the anode of the cell and transfer them to metal ions within the electrolyte near the cathode of the cell. The cell you constructed in the last activity forced the copper 2 ions in the solution to gain electrons and become copper metal. Cells like this can be used to electroplate one metal over another metallic substance. So can you think of a reason why this process would be an effective way to protect metals that can be easily oxidized? Electroplating is commonly used to protect metals from their elements in the environment that might cause corrosion. Iron and other metals are often electroplated with chromium, platinum, silver, or gold to protect them from substances in the atmosphere that oxidize them. Electroplating metal can increase the lifespan of the consumer good without having to actually make the entire object out of an expensive metal. So other uses for electrolytic cells. So refining metals. Recall that when copper is extracted from its ores, blister copper is produced from molten copper sulfide. Blister copper is 97 to 99% pure copper. Although this grade of copper is fine for many applications, it is still not pure enough to use for copper wires. Copper wires must be made with 99.99 pure copper. Further refinement is done using an electrolytic cell. In this figure, a very thin electrode of already pure copper is connected to the cathode. The blister copper is attached to the anode. As the copper in the blister copper is oxidized at the anode, the copper ions, or Cu2+ aqueous, are released to enter the solution. The free-floating positive copper ions diffuse in the solution and are eventually attracted to the electrons at the cathode. They move towards the cathode and gain 2 electrons when they come into contact with it. So by gaining 2 electrons, the copper ions are reduced to pure copper metal. Over time, the anode of impure copper shrinks while the cathode of pure copper grows. So electrolysis. Earlier in the lesson, we saw how electrolytic cells can be used to divide water molecules to form hydrogen gas and oxygen gas. This process is called electrolysis. Electrolysis is the decomposition of a substance by means of electric current. So in that figure, oxygen in the water molecules loses electrons at the anode to become oxygen gas. At the same time, hydrogen water molecules gain electrons at the cathode and become a hydrogen gas. The overall equation for this process is H2O is broken down into hydrogen gas and oxygen gas. So producing nonmetals. Electrolytic cells are not limited to purifying only metals. They can also be used to produce nonmetals. So in that figure, the chlorine ions have electrons taken away from them at the anode to make chlorine gas. Meanwhile, the sodium ions are reduced at the cathode to produce sodium metal. Both chlorine gas and sodium metal have a large variety of industry use. Chlorine is used to kill microscopic organisms in both drinking water and waste-resistant water treatment, and sodium is used as a reducing agent in refining metals like titanium. Rechargeable voltaic cells. So a rechargeable voltaic cell functions as an electrolytic cell when it is recharging. As mentioned earlier, a voltaic cell or commercial cell contains reactants that spontaneously undergo oxidation and reduction. When a cell no longer produces energy, the reactants need to be remade, and when you recharge one of these cells, you use an electric current to force the oxidation and reduction of the contents of the cell to reproduce the original reactants. Thanks so much for watching, and we'll see you tomorrow.